Hi, my name is Brianna Mikulich, and I'm the Product Training Manager here at aPriori. Today I'll be walking you through unleashing the power of digital factories, customizing process routings in aPriori. The first thing on the agenda is a high-level overview of digital factories, followed by a routing overview. After that, we're going to create a custom process in a live demo within aPro. But to start off, of course, I like to start off at the beginning, and that is with the digital factory overview. A digital factory is a virtual representation of a manufacturing facility within the aPriori software. Digital factories consist of virtual machines, different process groups, routings within those process groups, and processes themselves. A digital factory can represent your own in-house manufacturing facility, a specific supplier facility, an entire supply chain and their capabilities, and it could also represent a region. And if you're thinking of out-of-the-box aPriori, a lot of the baseline digital factories like aPriori USA or aPriori Mexico, aPriori China are all representative of a specific region. And really, at a high level, what a digital factory is it's your factory digitally simulated within aPriori. As I mentioned, aPriori does provide those starting point or baseline digital factories that represent common manufacturing capabilities in that region. So typically these baselines are non-industry specific. They are just a high-level overview of the general capabilities of manufacturing in that particular region. Then they have some regionally specific data that differentiates them. What we're going to be using in today's training is going to be the aPriori USA digital factory. So now that we've talked a bit about digital factories, let's take a bit of a deeper dive into the routing. The two main inputs required for costing in aPriori are digital factory and process group, essentially where it will be manufactured and how it will be manufactured. These two inputs will determine which cost models are referenced and which routings will be considered for the part. And I think that the easiest way to understand routings is to simply go through an example. So that's what we're going to do now. Here's a very simple sheet metal digital factory. In this sheet metal factory, there are two methods of manufacturing sheet metal parts. One routing surrounding the fiber laser cut, and the second surrounding a turret press. Before anything else, first let's look at the legend to understand the different boxes or nodes, as we call them, and what they mean. The first kind of node is a required node. I know that it's required because it has a solid line around it, as seen here for material stock selection. A required process must pass feasibility for the entire routing to be feasible. In this example, sheet metal is a stock-dependent process group, therefore the stock is required for the routing. The next kind of node are optional nodes. Optional nodes are denoted by the perforated line that's around it, as seen here for cut sheet to length, or CTL. Optional nodes can be included in the routing, but they don't necessarily have to be for the entire routing to be considered feasible. In this example, the stock is chosen, and then it asks, well, does it need to be cut to length to fit into the bed of that laser cut machine? Optional nodes can be included automatically if the geometry requires it to be included. Or they could also be added manually by us, the end user, if it's more accurate to real life. The last kind of nodes are activated nodes. Activated nodes are denoted by that pinkish salmonish background color. Examples here include a fiber laser cut, the bend break, and material stock. An activated node is actively contributing to the cycle time and therefore the cost of the overall routing. Now that you know the node types, let's look at the example part. Here is a simple sheet metal part, and it has lots of different geometry like straight edges and planar faces and curved walls. But for this example, we are going to focus on the 5 main pieces of geometry here, which are these 2 holes, these 2 bends, and a form. When aPriori first initializes a part, which is to say when it goes through the first pass of costing, what it does is it reaches out to the 3D to CAD model and it's going to extract all of the geometry and uniquely name and categorize it. Now on the right-hand side of my image here, we're going to see that unique name and categorization. So for this part, there is a category called bending and forming, of which there are two bends, straight bend 1 and straight bend 2. There's a form called form 1, and under the holes category, we have two simple holes, simple hole 1 and simple hole 2. aPriori will now look for a routing that can manufacture all of those pieces of geometry successfully. And of course, it will start with routing number 1. So based on the geometry of the part, which extracts the size, aPriori is going to cross-reference the size of the part with a predefined list of all of the available stock forms in this factory. That's here for material stock selection. Then it moves to the optional cut sheet to length node. In this instance, it's not needed, so aPriori moves on to the fiber laser cut process. Now what I've done here is I've included some of the different kinds of geometry that can be manufactured at the fiber laser cut process. And from this list, simple hole 1 and simple hole 2 can be manufactured. Now technically, this is the last required node in the routing, but there are still 3 pieces of geometry to successfully manufacture for this routing to be feasible. So what aPriori will then do is evaluate all of the optional nodes over here on the right-hand side. One of those, of course, is bend break. The bend break node can manufacture straight bends, which is great. There are 2 of those. So the bend break is now activated. It turns that pinkish salmonish color, indicating that it is going to be actively contributing to the cycle time and therefore the cost of the routing. All the rest of the optional nodes are then considered as well. But what results is that the form still cannot be manufactured as this routing is currently written. Then aPriori evaluates routing number 2. Material stock selection and cut sheet to length occur exactly as before, but then aPriori moves along to the turret press process. For the turret press, we can see there are more kinds of geometry that can be manufactured at this process versus the fiber laser cut. And from this list, the 2 simple holes and the form can be manufactured. And just like before, even though this is the last required node, there are still more GCDs to manufacture. aPriori moves to the optional bend break node, which can create those 2 bends. The node is activated, and it's going to now be included in the routing. For this example, all the routing alternatives in the factory have now been evaluated. Now aPriori must recommend a routing to the user, and this is how aPriori makes that decision. First, it looks for feasibility, and feasibility in this case means all the geometry is successfully manufactured. But once feasibility is established, then it will look at the lowest cost feasible routing. So once feasibility is established, it will then look for the lowest cost feasible routing. So feasibility first, cost second. In this example, routing number 1 will not be selected as it cannot manufacture the form GCD. Instead, it will select routing number 2 because all of the geometry can be successfully manufactured. So now that you understand a bit about how routings work out of the box, I want to talk to you about modifying a routing with a custom process. But before we jump into it, I do have a quick disclaimer. The following workflow is appropriate and is going to apply for only the currently open component, which is a part assembly or a roll-up in aPriori. It is not going to apply to the entire digital factory, only the currently opened part. If you do want to make more permanent changes to the digital factory, that must be made at the digital factory level. So who are you going to call? That's right, your digital factory manager. The part we'll use in our example is 189688. It's a simple sheet metal part from the previous example. The 2 most important required user inputs here are process group, sheet metal, and digital factory, which is aPriori USA. We also know it is made of a steel cold-worked AISI 1020 material with an annual volume of 5,500 units and a production life of 5 years. There is also a custom surface treatment that's required for this part that is not available in the out-of-the-box digital factory. Therefore, once this part is initialized, we will add the custom surface treatment. It's called top treatment, and it's going to cover 80% of the surface area of this part, and the cost is $5 per meter squared. So without further ado, let's jump into the aPriori Playbox instance. The aPriori Playbox is a training environment that has the 23R1 version of aPro and all of the parts needed for this example and other training. First, open the 189688 part in aPro by clicking the yellow file folder icon. Go to the desktop view, lab files, and find a folder called Explore aPriori. Find 189688.step, open. The part loads in aPro. And of course, start off in the cost guide over on the left-hand side of the screen. The process group for this part is sheet metal. The digital factory is aPriori USA. The material is the steel cold worked 1020, which happens to be the default for sheet metal in aPriori USA. And the volume and batch size will be kept as the default values as well. So for simplicity's sake, go ahead and click cost. Once the part costs, review the routing. The easiest way to get to the routing is in the validation tab, which opens automatically for parts. The selected routing is cut to length, turret, bend, but I want to look at all the routing options. The routing dialog opens and the selected routing is highlighted in green. There are two feasible routing options. Those are turret press and laser punch. I know these are feasible because they have a cost over in the right-hand cost column and no visible errors. That's opposed to CO2 laser, fiber laser, and water jet, as they do have costs, but they also have errors. And if I hover over that fiber laser that we discussed before, we can see in the tooltip that it cannot manufacture the form. But what I'm interested in right now is a surface treatment called top treatment. So on the top level routing, I will expand all the surface treatment options and see what is available. However, I don't see the surface treatment the supplier told me about, so I want to go ahead and create a new process. To do this, find the Edit dropdown in the top left-hand corner and select Create Custom Process. Name it Top Treatment and specify how the cost will be calculated. Cost could be added as an investment cost or a margin percentage. However, in this example, it will be cost based on the surface area of the part. So under the model type section, select cost per surface area. The rest of the table is laid out in the same order as the drop-down list under model type. Therefore, scroll down until the cost per surface area category. The first thing it asks for is the surface area of the part. This could be automatically extracted from the geometry. It then asks for the percentage of the surface area, which is 80%. Lastly, it asks for the rate, which is $5 per meter squared. Click OK when done. The custom process is created and a menu appears on the left-hand side of the window. Expand User Defined to find Top Treatment. Drag Top Treatment over to the surface treatment list on the top line routing. Place it between blast and vibratory finishing. This will apply top treatment to all routings regardless of which option is selected below. Recost by selecting Apply. After costing is completed, notice that the surface treatment is now activated, and if I expand that, I could now see the inclusion of top treatment. The cost in the right-hand cost column has also changed, but I could see that a little bit easier if I close out of this window and navigate to the cost summary. Here there are the deltas from the previous cost event. It went from $1.32 to $1.58. Also in the manufacturing process panel, notice the inclusion of the surface treatment top treatment. This concludes the demo of creating a custom process and adding it to a routing. Thank you so much for your time and attention today. I hope that this was very helpful to you. And if you want additional product training, please visit our training website at www.apriori.com/training. Thanks and have a great day.